Sample problem 8.03. In the given figure, a child of mass m released from rest at the top of the water slide at height h equal to 8.5 meter above the bottom of the slide. Assuming that the slide is frictionless because of the water on it, and find the child's speed at the bottom of the slide. So in this diagram, we have to see a child is sitting on the top of the water slide, and it is a frictionless slide because of water on it, and the child is sitting at a height h equal to 8.5 meter from the surface of this water, and we have to consider the initial speed of the child is 0 because she is at rest. And then when the child is coming through this water slide, we have to find what is her final speed. That means Vf we have to find. So for that, let's we take two position. This is our initial point and this is our final point. Clear? And for finding the answer for the final speed, we have to use the conservation of mechanical energy. What is conservation of mechanical energy? We have the rule kinetic energy initial plus potential energy initial, which is equal to kinetic energy final plus potential energy final. This is the rule. Now we already know the formula for kinetic energy and potential energy. So the kinetic energy formula is half mv square and the potential energy formula is mgh. So I have to substitute this formula in this equation. If you substitute, what you will get for this initial kinetic energy, I have to write half mvi square plus, and for potential energy mghi, which is equal to this one, half mv final square plus mgh final. Now let's we see the left hand side of this equation. So this is our left hand side of the equation, this is our right hand side of the equation. Let's we see the left hand side. So this is our initial, so that means initial. In this initial, the child, you can see the initial speed of the child, they clearly mention c is at rest. That means the initial speed is 0 meter per second. So when you substitute vi equal to 0, this will be gone. Am I right? And here hi value, because from the top, from the bottom to the top, the hi value they clearly mention as 8.5. So we will get some answer for this part. At the same time, when you come to the right hand side, the most important thing, we are going to find the final speed. So anyhow, we will get some value here. But the most important thing, what is the final heights when the child comes through this water slide? When she will reach the bottom slide, what will happen? The height final, which is equal to 0. So this will become 0, because when you substitute hf equal to 0, what will happen? The entire term will get 0. So only we have two formula. One is in the left hand side and the right hand side. So left hand side we have mghi, right hand side we have half mvf square. So now the most important thing, mass get cancelled with this mass. So what is remaining? Ghi, which is equal to half vf square. So here we are going to find the child speed. That means vf value we are going to find. So we have to rearrange this equation in terms of a final speed. So therefore the final speed square, which is equal to 2 multiplied by g multiplied by hi. So therefore vf, which is equal to square root of 2 multiplied by g multiplied by hi. So now I'm going to substitute the value here. So 2 multiplied by 9.8, and then height from the water surface to the child, the initial height is 8.5. So for hi, I have to substitute the value 8.5. Now let's see what is the answer. So this is 8.5. So I have to find the answer. 2 multiplied by 9.8 multiplied by 8.5. I got the answer here as 12.90. So the final speed when the child comes to the bottom of the slide, the child speed, which is equal to 12.91 meter per second. So this is the answer for this question. That's it. Thank you.